Hello again, guys. What is up? I'm Ferris. This is another episode of Ferris Makes Emulators, I think, right? Thursday? Yeah, pretty sure. Anyway, this is the 20th emulator stream, which I am pretty stoked about. That is something like a milestone or something, so that's pretty cool. I call this one Debugger digging, I believe, because we're going to be digging around a little bit in the debugger and actually a lot, I think, in other emulator source code. I'll get into why in a second. Anyway, this last week has been quite productive, as was the week before. You'll notice the website has this cool demo reel thing here now. Generally a little wider, looks a little bit better, and I put up a little blog. Moved over some stuff from another blog that I have. Again, this is rushtoaboy.com if you guys want to check it out. Yeah, also ported over one of these articles where I debugged some stuff in Mario Tennis, so that's pretty cool. So that was pretty nice. That's just on the front side of things. In the emulator itself, also some more progress there. Let me pull that up. Bloop. How's it going? DevPram, F-Note, John Hunter 9, TJ, Daniel Collin. Did I say DevPram? I did say DevPram. How's it going, guys? Thanks, Daniel Collin. I also am pretty happy about that website. I think it looks just as good as it needs to for this project. There's been a lot of pull requests, I believe. Let me look at the commits. We got Dr. E-Man. Replace some stuff with, I was checking the number of bits if they were 1 to see if something was a power of 2, but I didn't realize there was actually is power of 2 for at least U size. That was pretty cool. Sebert and I believe it's Bob Twinkles, it's a fun name, are working on libretro integration, which I'm really, really excited to see. That's being done in its own repo. And progress looks like it's going pretty good. I know there's a lot of metadata that is working already, basically. So it's just a matter of like getting the emulator itself hooked up and everything. So that should be really, really cool and should happen pretty quick here. And there's been, I believe, a bunch more small stuff. Jay Westfall has been implementing like the CPU cache and stuff, which I don't know if that got merged last week already or not, but it got merged at some point. Still not being used for any cycle counting right now, but it is actually a little more accurate. But then more recently, of course, he implemented the rev subopcode, which just takes a 32-bit integer and just flips all the bits around. So that's pretty cool. Another thing on the way to libretro integration, this was pretty cool. Let me look at this. We now split up the Rushtoaboy crate into 2 different ones. There's now the core and then the CLI. So the CLI is the current front end we have, which is just basic CLI front end. The core is the actual core emulation. And it looks like we're going to introduce another one, which is going to be a bunch of middleware that you might use if you implement a front end, but then you don't necessarily have to have it. Again, this is just to make it simpler to integrate with things like libretro or another front end or whatever. So that was kind of a nice change. Also fixed a bunch of CI stuff after that. And other than the website stuff, I can't remember anything major, but I could be wrong. So if someone points something out, no worries. I'm a bit tired today, by the way. So if I'm all stumbly on my words, that's going to be why. Anyway, the bug and vertical force in particular, or actually let me just show you what I want to look at in particular. I'll pull up this repo again. So if we go to the repo, which of course I should have just clicked the source button, links and stuff. I think I did this was it last weekend? Or I think I had this on the stream last time where I had this compatibility table of all the games. And so basically empty means it's not compatible, and I'll talk about why in the notes and stuff in this table. F is fully playable, and A means like, oh, for this region, this game doesn't exist. And then P is, F is fully compatible, and then P is like, okay, you can play the game. We know the game is playable, but there might be some issues like this. Now, if you look at this table, the most bang for the buck we're going to get is implementing like the bit string ops. However, I just don't want to do those right now because I'm a bit tired. So I'd rather kind of dig into some of the other bugs we already know about. In particular, vertical force and space invaders both have bugs that might be related. In particular, vertical force, enemies' power-ups appear and disappear. First boss disappears in the game soft lock, so it's kind of weird. I'll show you what that looks like. Let me pull that up here. I believe I've showed this already, but I thought we could dig into that this week. I'm just going to go through some menus. So when you go into the game, you'll notice, check out these power-ups here, how they disappear during half the sinus cycle. Really weird, but I'm pretty sure it's something with the CPU. If we let the game run a little bit more, there's another power-up here that starts disappearing. There'll be some enemies on the left that come up here, then they'll start disappearing. I think it's these guys. Maybe it's not them. Another power-up that disappears through half its cycle. Now, I believe it was last weekend, maybe it was the weekend before, I did some, that's these guys disappear. It's weird that they all seem to be on, those disappear as well. Yeah, a lot of these seem to be on like sinus patterns, so it's kind of weird that, yeah, a lot of them just disappear. I did some work trying to figure out what this was, either last weekend or the weekend before, and I did find some subtleties in some of the floating point ops, in particular if, like I found a corner case where if like an add or a subtract for floating point numbers ended up being -0, it would actually be rounded to 0 by the hardware. But I fixed that on a branch, didn't seem to actually fix anything, so I just kind of left it alone. I didn't actually merge that to master just because we didn't see any actual visible change. So yeah, it's there on a branch if we decide that's something we want, but yeah. So other than that, I have some notes that I took, geez, maybe a month ago now. And other than that, I just think we got to start digging through some code and seeing if we can find something. Defram said that the table is confusing because F could be fail and P could be pass. Cries, how's it going? Also agrees. That I had not considered. Maybe that is a bit confusing. John Hunter 9 says color codes. That could be useful as well. Yeah. Could probably improve that. I'll probably leave it as is, though. If someone wants to open a pull request, then I'm happy to take that. But I think the metric is fine, at least, where we have like one that means it's totally compatible, one that means playable, and then basically anything other than that is blank. And also I have this metric here that's 71%, and that's basically calculated by all the ones that are playable or fully playable over all the possible cells that could be filled in. Anyway. I'm guessing both of these for the USA and the Japan one for vertical force will work once we get this, but we just got to figure out what it is. It seems to be pretty obscure because I did. Remember Ryan says use the emoji check mark. Yeah, that could totally work actually. Use emojis for these. That's the idea I like even more actually, because then it wouldn't be any ambiguous letters. Yeah. Yeah, so I did some digging a few weekends ago, where I just went through the data sheet for the CPU, and I went through basically all the ops, and I couldn't find anything obvious. And so that's why I want to look through some other emulator code. I can also bring up the notes that I took at one point. So this was actually digging in the debugger, and I can just basically show you the kind of process this was. Pull this up here. So the first thing that I was thinking with these things that appear and disappear, I was thinking that, let me step into the bugger. I was thinking that these things in particular that come in and out, that those would be like if they, I wanted to see if they had like a weird position in the video hardware because I wanted to rule that out. Turns out that there's a little table of like all the windows that need to be drawn, all the objects that need to be drawn, and there's no entries for any of these objects when they disappear. So it seems like a logic error. So I basically ruled out that it was the video hardware, and I started like digging into the code to see what was writing to those registers. I got a few of these different routines here. Like this one copies a bunch of stuff out of memory into these object pointers. So then it means that wherever this memory was pointing to is the actual object pointer, which I found was this value. And I started looking at some of the other code. I started like disassembling some basic conditionals. But generally, there's just a lot of code here. Not necessarily the stuff that I'm showing you here, but other than this, there's just a lot of code. And I think sifting through that is going to be pretty tedious. Especially when we know that there are some other CPUs where this game works fine. In particular, in Mednafen, it seems to work okay. So we're more compatible with a lot of the games in our emulator that work right now, but this game in particular seems to work better there. And I have a feeling that going through each of the ops of the different opcode implementations against something like that is just going to be a lot easier and a lot faster. So we kind of want to see if we can get a quick win from doing that. So I kind of want to start there today. F-note, what could we use for partially working? the monkey. Yeah, I'm not really sure. Cries, is there a non-3D mode in the emulator, by the way? Not right now. Would be pretty easy to add one. Just basically disable the parallax when drawing to the left and right buffers. So it should be possible to add one, but also now we're using clap for parsing command line arguments. I can't remember if that was something that came in the last week or not, but it did. I think that was Bob Twinkles that did that. So if anyone wanted to add a something like that, I would not mind accepting that. Yeah. Anyway, I guess we can start digging a bit. So again, the reason I'm looking in other source code in particular is because I did look through the data sheet at one point. And I couldn't find anything obvious. So I'm just trying to look at other emulator code because I think that, like, just because it's written differently, we might find something interesting. So what I think I'm going to do is basically go through all of our opcodes and all of the all the opcodes in Mednafen. In particular, I have it open here. This is the libretro mirror. And I'm using this one because I specifically tested this core when I tested if the game worked in the emulator. And it does. So I know at least this code works. So yeah, so I want to compare it to this, just to see if we can find anything that may be somewhat obvious. Again, we might not find anything, but this is just going to be one of those days, I think. So in the Mednafen source, it's in this. I'll actually post this link to the chat as well. If you guys want to dig around in here. This is libretro mirror / Mednafen git. And then in the source directory, there's a bunch of folders for different systems. You might think the CPU is in the VB, but it's not. It's in HW CPU. And that's because they also have a PCFX emulator, which has the same CPU. I believe it's PCFX. So in here we have the V810, and this is basically what we're looking at. Now, a couple interesting things about this. Mednafen has one of the... It seems to have a pretty accurate CPU. I believe it was a different person that wrote it than who wrote the rest of the emulator, which may or may not have something to say with that. I don't really have an opinion, but the CPU seems to be like, it looks like it's pretty accurate. It looks like whoever wrote it really cared about accuracy here. And they do some funny things. For example, all the floating point ops are actually done in software. They use soft floats for everything. Now, I think that this is because they also do the floating point exceptions. So they'll detect like division by 0, or they'll detect, I believe it's like precision degradation is one of the interrupts, stuff like that. In order to do that, you really kind of have to do soft floats to understand when those conditions actually happen. So that could make sense. In fact, yeah, like here's overflow. Here's a reserved flag and stuff like that. Now, this is something that's a bit extreme, and unless, like, I think the only real thing that warrants doing this is going to be the exceptions, because, like, it is IEEE 754, so just using F32s with the Rust code should basically give us the same results mathematically. It's just, yeah, detecting these kind of edge cases might be a bit tough. But anyway, so that's one of the, like, glaring differences in at least the floating point stuff that I don't think the bug is in. It could be, but my gut feeling is it's not. And at some point, looking into this and maybe trying to do our own soft floats could probably be worth it, again, if we're going to look into those exceptions. But my gut feeling is that's not where the problem's going to be. So not going to worry too much about that. Also, because we're not raising those floating point exceptions, I also don't think that's the problem, because those are really supposed to be very exceptional cases, like a division by 0 or something really weird. Again, I don't expect the game to misbehave without that. So Dan Colin is asking, yeah, have you verified that the game doesn't rely on these exceptions? Yeah, I don't think it does. It could, but I don't think it does. Checking for that would also be kind of hard, I think, without the emulator actually checking that stuff. I guess we could somehow debug this code and try and find out, but my gut feeling is that's going to be kind of a red herring, because it should be pretty weird stuff that would cause that to happen. Yeah. So I just kind of want to go through some of the other ops just to see if we can see anything obvious. Now this is going to be a bit of a slog because there's a fair amount of code here, but I think it'll be worth it. Because it's one of those things that at least if you go through, you kind of know that it's more or less correct. Like at least we looked. Also a bunch of stuff about like clearing and saving the cache, which is one of the few emulators that I know that's actually doing this, which is pretty cool. Although we're not far off from doing that ourselves, but I have not seen a game that tries to do this yet, so haven't looked into that. I think it was in here that had all the ops. I could be in the wrong source file because this CPU is in like 6 different files. But I'm basically just looking for any ops I can find and then just going to start going through theirs and comparing them to ours. If no, could try commenting out the exception lines from Mednafen. Yeah, that could be. John Hunter 9, negative numbers. I believe our floats should be processing negatives properly. But yeah, I guess could do that and then try to build Mednafen. That would be a pretty good way to test that, but I still don't think that's what it's going to be. Because it would have to be really weird stuff going on for that to happen. That's the kind of stuff that usually like crashes or breaks into a debugger. So reg, get reg, cpc. Might have to look at these methods in a sec. Here's run. Get register. So I'm not that terribly familiar with this code, so that's why I'm just kind of going through it. Just scrolling through because I don't really know where things are yet. Looks like we're in the bit string ops, which we haven't implemented yet. This game doesn't appear to need them, otherwise it would have crashed in our emulator. Just digging. Here at least we have some dispatch stuff. Don't think it's that. And I also definitely don't think it's going to be like like we have some opcodes encoded wrong, because I think we'd have much bigger issues if that were the case. I have a feeling it's going to be something subtle with flags or something. These are trivial. I can just look at these here, though. Like XB is basically swap the bottom 2 bytes. Could actually just start with that. Yeah, we're basically just going to swap the bottom 2 bytes here. That looks fine to me already. Although does this take in reg 2 and do reg 2? This is arg1. Which it looks like, according to the arg1 and arg2 here, are actually swapped from the different registers here. You can go ahead and look at that, actually. Okay, apparently that's not used in this code. Here's the op table. Is this CPU.cpp? I don't really know where the dispatch loop is, so I'm just kind of punting here. I seem to recall there was the actual implementation of a lot of these instructions in one of these headers. Could be wrong though. Yep, I'm wrong. That was the end of the file. Could try up loop. Some other opcode table. String subops. Do you call in sync code and search offline? Yeah, I could do, but I don't think there's that much code here. Just feeling real slow and lazy today. F note, could it be something to do with floating point to integer conversion? So that was one of my initial thoughts. I need to double check that, but we'll check that when we get there because I did think that initially, but I've looked at that a few times now, and I don't think that's it, but it could be. So we'll check that again when we get there. Dr. Difference, how's it going? Glad you could catch me live. I'm also seeing that it seems to do, like here it said arg2 and arg1. I wonder if those are like begin op. Not really sure how this code is structured in that sense yet, but. F note, I think a negative float to an unsigned integer doesn't produce the expected result in Rust. I think I tested that specifically actually a couple weeks ago. Is it playrust.com? Nope. It's play.rustlang, isn't it? Yeah, actually it's Dr. Difference, thanks for the follow. This was something else. I think someone posted this in one of the previous streams. So this is not what I was thinking that I was messing with. But yeah, at one point I did something like let x is negative 2f. Let y is x as u32. And we print y. Oops. In fact, we can even print x and y. I believe that's what we'd expect. We'd basically expect the same thing as casting this to an i32 and then to a u32. So for example, if we do make this like z, right? So we're going to take the original float, cast it to i32, which should basically be a negative 2 as well, and then we're going to cast that to u32. We should get a redonkulously high number for z. But that's what we expect. So this seems to behave consistently. Just as another check, we can even do this just to make sure that those are the same. F note, I tried negative 3 to u32 and got 0 in debug mode. It's a bit weird because I am in debug mode. Try and release. Can also try with -3. Oh, hey, what? So in release, that's odd. I still don't think this is the problem though, because I definitely cast through i32 for all these. I can double check, but fairly certain about that. That is a very odd result though. I'm not too thrilled about that. Yeah, so for example here, round as i32 is u32. That is quite strange though. I don't really know why that's happening. Evan says, I believe converting it out of range float to integer produces a garbage value. Could go spec digging and dig that up. But at least going through i32 gives us the right results, and I'm still fairly certain that's what's going to end up happening here. We can even do round. I'll do round here. Test a couple different paths. If you guys want to do that spec digging, feel free to post it, but I'm just too tired for that right now. Need to do something more brainless. Yeah, it's a bit of a weird case. If not, says you'll see the same sort of thing trying to cast like 257 F32 to U8. Crisis, I feel like either both or none should work. Yeah, it's a bit weird that one works and the other doesn't, especially that they're different in debug and release. Not really sure what that is. I'm definitely setting a bad example, not looking into that further, but that is just not the kind of thing I want to deal with right now. Yeah, and again, like these, so this is one of the CVTSW where we do yeah, because I do one where I do round, I do another where I do truncate for the different conversions. As long as we go through i32, I believe we get the expected results. Or is it trunk? I can't remember. One of these just truncate the value. Dana Colin, have you tried the game in debug? The truncating it, by the way, works. A bit funny. Yeah, I can post a playground link. I'll get rid of these rounds because they are not necessary to show this. How do I get a link with the same code in it, though? Actually, I don't know how to do that on Playrest. Oh, yeah, I was on debug when that had trunk. Yeah, that's true. Still broken on release. Server says Freefold posted the issue on Discord. It's a known compiler bug. Sorry, Separate. My links are disabled. I'll add use one of the regulars. Who in second? Yeah, sorry guys, I'm not on like Discord or Slack or anything when I'm streaming. Just easier to turn that off so I don't have to get distracted by the notifications. I'm distracted enough already. Looks like we had a link here from Cries. Floating point teacher cast can cause undefined behavior. From 2013 even. Very interesting. Just to be cheeky, I'm going to try the emulator and debug. Again, I don't think our code is going to hit that corner case. But apparently it's a bug. Good. If just running into bug fixes it, I'm gonna be annoyed because I've looked through these the code for these opcodes a couple times. Like if this will be slow. Oh yes, this will be very slow. Guys, it's not a bug, just undefined behavior at the moment. Compiler dev cop out. Oh, that speed though. Is this even catching the key presses? We should at least be able to get through some frames. This might just be too slow to do this. Yeah, Colin, wouldn't save states be great now? Well, not if the save state was produced by a CPU that didn't work. I'd like to have at least find out if there are any overflows. Yeah, if we even get there. If we ever get to see the screen that see what happens. Sever tried to bug it at one point, made his laptop unusable. Not surprised. What's the difference? Well, why is it so slow in debug? Because a lot of the stuff that gets optimized away, like with iterators, certain kinds of bounce checks, basically all the overflowing integers, stuff, all that kind of stuff would normally get optimized away. And it doesn't in debug. Remember that this does actually do a lot of work per frame. So frankly, I'm not that surprised. Cries could try the debug config to 01. But is that going to matter? Because my gut feeling is that this undefined behavior had to do with optimizations. So if we turn on optimizations at all, 66, my NES emulator worked around 30, 40 FPS in debug mode. Can't imagine how slow a 20 megahertz CPU would be. Well, it's pretty slow apparently. Now, and I think that there are some bits of this code that are not the fastest either. But yeah, it's pretty slow in debug. Note that I've not tried to ever run this in debug, so I'm not that surprised that it's this slow. Or like not, yeah, have not optimized for this case at all. Yeah, someone could tell me how to actually post the playground link with a specific code. I will happily do that, like I said before, but I don't know how to do that. So, Yeah, we'll modify the debug config. See if we can get that out. Guys, is the short button on top? I'm not sure which button you're referring to. It's not this guy. I'll try this. Oh, the shortened thing here. There you go. Never mind. There you go. Oh, whoa. That link didn't look like it worked very well, but it should be cool. Yeah, I'm sorry, guys. I am tired today. I was not kidding. I'm not surprised I'm missing that. Let me... That's probably a little better. Feeling like there's a lot of backseat yelling at me in the chat right now. And I'm just going to stop listening if that continues. Just going to stop reading. In no mood to deal with that. This is what I was after here. That seemed to help, or did it not? I don't think it did. It didn't seem to rebuild anything. And I don't think we have to change that for all the crates. I think we only have to do it for this one. Crisis is changed with up level 1 and above. Oh, did I just leave it as 0? Jeez. Yeah, this is the code Crisis posted. That looks correct. Like, this looks to be the same. Except that we store on the stack here. Up level 1 is already bad. Yeah, no, as I wrote, even with no optimizations, you get bad values. They just differ. The bad values you get with optimizations. Guys, if you want to catch that link, Dr. Difference just posted. Just kind of curious to see what that was. Yeah, and this is still ridiculously slow. Probably due to lack of LTO. Could try. But again, I still think this is going to be a stretch. And yeah, this is up level. Yeah, I think this is just going to be red herring anyway. Because again, I think that even though there is this undefined behavior bug, the only time we're even doing those casts, it's pretty controlled what we're doing. There's a difference. I had not actually checked out the EmuDev Slack community, but it's probably pretty cool. Yeah, this is a strange bug, but again, I don't think it actually will affect our code. Because literally the only time we do these casts are here, where we do round as I32 is U32. Which appears to work correctly for the cases we have. And then there was one other one where we do truncate as I32 is U32. Jay Westfall maybe is a debug line to print the value and see if it's zero while built in release. Yeah, that actually wouldn't be that bad of an idea. Just to see if we're getting something like that. I mean, I'm guessing there will be a lot of casts, so this will probably happen pretty often. Maybe it won't though. So we'd want it here. So then what we'd be looking for yeah, that's a good catch, Daniel Colin. We'll check if the original value was negative. Daniel Colin, or you can verify that you get a value you expect. I guess we could do, like, the thing is I don't really know what kind of values are going through this function initially, so it's kind of hard to set up a case that where I would expect that. But let's just try doing this. See if the original value is less than 0. Oops, this should have been and. If the float version was less than 0 and we get 0. Still could do a bunch of false positives here, but we'll give it a shot. And of course, this was not correct here for the literal. Cha. So when those things start disappearing, we should basically see prints if that was what was causing the issue. And that's not the case here. Guys is saying it's also undefined behavior in GCC and Clang. And generally in C++ shouldn't be a problem. Yeah, I still don't think that's going to be the issue again, even if it were not something that, like, it's not something I would have expected to happen, but again, all the places that we actually do these conversions, that doesn't seem to matter. I think that's a good enough test, because otherwise we're going to have to see the different values. I mean, could even just see... Evidence says the value won't necessarily be 0. Yeah, that's true. Here's something we could do, though. Just print all of them. Which may print out way too much stuff, but I don't know. At least we'll see. Again, I still think that this is not where our problem's going to be. But why not? Why not? It's kind of weird that we're not seeing any of these yet. Yes, this isn't even using the floating point stuff right now. Because we should definitely have hit one of these if it were using floats like at all. Well, that's not really true. Because that's only if it's converting the floats to integers. But it should really do that for most useful things. At least if it's going to be using those for like positions or something. But I mean, so then it's not even using these. Let's find a ROM that I know uses these just so we can be sure. Pretty sure bowling does. JOSFL, yeah, I don't think it's used in FP. Yeah, if not, I also think not really going to be a problem here. Okay, this was a game I thought would have used this. This is kind of weird. Expecting to see one of these. But I can't remember really which games actually use this. Pinball will use it, for sure. Use it for the ball position. I remember debugging that, actually. Yeah, I also think lookup tables are common for sine cosine. Yeah, so here we just got a bunch of conversions. It's spat out. And these are all looking great, actually, including cases that would have caused that issue. This is the kind of stuff we expect. Yeah, I'm fairly convinced that this is not going to be the issue. These are all convert, so they're going to round. So all these numbers look correct. So that pretty much rules that out. And I'm not that surprised that that's not going to be the issue, because I've looked at that logic a lot of times now. It may be like setting wrong flags or something, but yeah, I've looked through that enough times that I'm not that surprised. All right, where'd my stuff go? Here we go. Okay. So here's move. Just go through in mine as well. Find move. Now there's two different kinds of moves. This is move register because it moves from one register to the other one. I believe move doesn't set any flags, so that's move reg. In fact, these might actually be in the same order because I believe we use the order of the actual bits of the opcode, so that should be nice. So in this case, we read from reg 1 and store in reg 2. This looks like they're backwards. Oh, no, that looks fine. Yeah. F note, could it be an issue with signed integer division? Yeah, let's just see when we get there. We're going to be jumping all over the place if we try to find the short pass. It's possible, but I also don't think that that's the case because I'm pretty sure I was careful there, but we can see when we get there. So move looked correct, and this is add clock 1, which is we basically do that anytime where the clock isn't mentioned or the number of cycles isn't mentioned. It's basically going to be 1 cycle because the way this works. So for add, it's going to be another 1. We're going to do arg2 plus arg1, which I actually have an add for this, but yeah, take reg2 and reg1, and we do add. I'm going to just find that. So the add here does a couple things. First of all, we get I do overflowing add here, and then we get the result and the carry, which is what that should give us. Here it just does it if, yeah, the result was less than arg2, which is less than the left-hand side, I believe. But I'm pretty sure we're going to get the same thing with overflowing add. See you later, TJ. Thanks for watching. I mean, we could actually just do this because it's pretty simple anyway, just to try it. So we don't use this overflowing add. But I just figured that would give us the result we wanted anyway with this carry. We'd still want to do overflowing add and overflowing sub in order to not panic. So if we did that, it would look like this. It's going to be, what's the res is less than LHS. And then I'm also looking at sub. Yeah. There's also the overflow stuff is kind of jank, but that's another thing that I spent too long on when I implemented it, just trying to figure out what that would be. There's like well-defined logic tables for it, and you just kind of have to interpret those and write those out. Oops, this is not the right game. Yeah, so that didn't affect anything. And I'm not that surprised. Cries, don't you want wrapping add then? Yeah, I guess so. I think the only difference is whether or not it returns the carry. I mean, I can put it back just to be sure, but I'm guessing we're going to get the same result. It's just the only difference is that wrapping add won't spit out the carry. In this case, wrapping sub. C2C, how's it going? Cries, so it doesn't matter now. I'll still double check while we're here. Because like I said, I've actually gone through this a couple times with just the datasheet. So I'm willing to try kind of stupid stuff like this. Because, yeah. I missed it enough times that I just want to find it, even if that's what it takes. But I am pretty sure that when I looked at it, that was the difference between overflowing and wrapping. Zach Jeff didn't watch earlier. What issue are you having? The ships are disappearing. I can just show you again. It's the power-ups initially, but then if I play to like the first boss, the boss of the first map or whatever, I don't even know what it's called. I haven't played this game enough. Then the boss will like come down to the middle of the screen and then just disappear, and then the game soft locks. Like you can still play, but you're stuck. So these power-ups, they just disappear and then reappear. Really weird. Yeah. And debug mode's really slow. It's the other thing you missed. I do want to double check this overflowing logic, but I'm fairly certain that's going to be correct. I'm also fairly certain that this one's going to be different. So what it's doing is it's basically saying if the left-hand side, so first of all, this and at the end here is basically going to isolate the sign bit, and then you can basically determine the overflow as a function of the sign bits of all the inputs of the integers, or of all the values. And in this case, it's going to be if the left-hand side's sign bit is not equal to the opposite of the right-hand side bit, which I've encoded a little bit differently, where I take the not equal to and then invert it, which should be the same thing. And the left-hand side's sign bit is not going to be the result sign bit. So I believe this logic is the same here. Yeah, Daniel Colin, it's definitely when it goes to like the left, and from some of the other sinuses, it looks like that's consistent, but I'm not entirely sure. So when it goes negative, and that's why I'm kind of suspecting one of these subtle things, with like the overflow or carry flags. So I want to double check all those. But it's something that doesn't seem to affect any other game, except there's a bug in Space Invaders that I suspect might be the same thing. And I'm just not going to bother with that until we fix this one first, and then I'll test that out. To the dark side of the sign table, John Hunter, yeah. So, I mean, just to be sure, I can also do the exclusive OR here and then not this, because it's basically going to be that, I believe, in Rust notation. But I'm pretty sure that ends up being the same thing, right? It's actually the ship's signing out. Nice. Cute. Yeah, and in this case, this is actually exactly the same logic. Except this here. That's the difference. I need to find the table where I got my values from initially. Let's just try this. Now it totally broke. Which is really interesting, actually. That's really odd. F-Note, I find it interesting how you do shifts one bit at a time. I wonder if things could be sped up without changing correctness. I don't see a bug in the shifts. Shifts one bit at a time? I don't really know what you're talking about. Oh yeah, doing the actual like the shift opcodes. Yeah, I do this one bit at a time. That's for simplicity. Could probably be sped up. The other reason I do that though is to detect the carry, because it makes that logic a lot simpler. But that's why I'm doing that. Oh no, seriously said, oh no, comma, truth table is required. Yeah. This was actually really weird though that this affected that so much, because this matches the logic here now. Yet I know the game runs in this emulator. So that makes me a bit uncomfortable. I can't read that name. F Master. Thanks for the follow, man. That's really strange. arg1, arg2 minus arg1. Which will basically get there as well. Like, first of all, I'm pretty sure what I had here was correct based on the truth tables that I found for subtraction. So that was weird anyway, and the fact that it was wrong is really disconcerting. So that's a bit strange. Just to try this, let's just try and match what they have, and then also do the same for the carry. So this affects both the subtraction and the compare. And maybe in theirs it's different for the compare, which is right here. Here it looks to be the same. So then why did this matter? So that should be the flag logic they're using. Just to try that, to see if it affects anything. That's weird though that it made the game just... So I don't know if you guys can see what happens. The game just doesn't boot now. With that change. That's concerning because that's what I had before. Cryos is LHS, isn't it RHS? It shouldn't be because you subtract reg 1 from reg 2. So it's reg 2 minus reg 1. So that's why I'm doing LHS there. See, arg2 minus arg1. So that's why I'm taking LHS there. Those numbers come from the register order. That's what they're referring to. Yeah, they have arg2. Arg2 is the left-hand side. Probably the chat delay is why I'm confused at your response. Yeah. Which is actually convenient that we're using the same, more or less the same notation. But this is so weird to me that that's how that is. And that it breaks in this one. And this I'm still sure is correct. So they do the not before this XOR here. It should be fine to do it after this expression here. If note's back, we're just still digging through add and sub. That's so weird that this logic ends up making it not work. And I don't like that at all. Just to be sure of something. This should give me all 5s. In hex, though. Yeah. Just to make sure that that was the right operator. Mm-hmm. Yeah, also you know that notice my sub and set flags here doesn't actually use the result, and that's because it returns the result, and then sub up here will actually then set the register result. but then compare won't. So that's the difference there. But why were they getting away with this? I find that deeply uncomfortable. Another thing to look at is if these like arg1 and arg2 probably up. If those are the type we expect, which they should be. Do we wrap around here? Think we might have. I think we did. Looks like here they're basically doing UN32s like we expect, which is what we have. Get in or get out when in doubt, printf. Like, Jeff, maybe you could try the subtraction code in a test or in isolation to see if it gives the expected results. Yeah, the problem with the overflow is I always have trouble figuring out what the results should be. And it's so weird too that again, like, so this logic again I got from some truth tables. I need to find those. This one. If you Google binary addition, if you Google binary addition overflow, you'll find this. And basically, so yeah, rules for returning on the carry flag in binary integer math are 2. The carry flag is set if the addition of the two numbers causes a carry out of the most significant bit when the leftmost bits are added. Carry borrow flag is also set if the subtraction of two numbers requires a borrow into the most significant bit. And yeah. Later there are these truth tables here. It can only happen when the two numbers of the same sign, when adding two numbers of the same sign and getting a different sign. So detect overflow, we don't care about any bits except the sign bits. So you can ignore the other bits. And you have overflow in these two cases. But if that's the case, then we can set up a test pretty simply, I think. Here, I'll fix the link thing if not. Yeah, so I agree with you, F-No. That's what I think, and I think that's so that left-hand side of that expression I think is equal. So you see again that's not that's F-No. So by the way, Kryes is one of the moderators, so that's why he's like reposting stuff, and then the other people are saying. So sometimes it's not what he actually said. Yeah, Suzuki's showing some interesting things about this flag. Like we can set up some tests here. test a couple corner cases. Whoops. Yeah, we can comment out some of these here. Yeah, I also think they're going to be equivalent. So that's basically we're checking if this here. Let me zoom in a little. If this here should be equivalent to this, and I think it should be. Yeah, so Carter's asking what the difference between overflow is and carry for the subtraction. So carry. Here, let me pull this up. Carry is what you would expect. Like carry is set if you do an integer overflow, and this is why it's so confusing. Carry is set if like the addition would produce an integer overflow, like you basically do like wrapping add and it wraps around, right? But then overflow, I think, has to do with if the numbers were interpreted as signed, and you end up having to, I can't remember the exact condition, but it happens here. Like if you have two numbers of the same sign and you get a different sign. So I think the condition is that if you're treating the add as two signed numbers, and you get a result that has the wrong sign, then the actual addition should have given you, is I think what it's meant to represent. So it's kind of like an overflow in a signed number sense. Whereas carry will give you that in an unsigned sense. I think that's what it is. But this is actually something that I don't have a very good grasp on. So, but that's why it says basically to detect overflow, we don't care about any bits except the sign bits, and we can just say overflow can only happen when adding two numbers of the same sign and getting a different sign. F note, couldn't you convert the numbers to signed and do the overflowing addition again to get the overflow flag? You're like I32 overflowing add and U32 overflowing add? I suppose so. I guess I'm more disconcerted because I know that this should be correct. I'd be really surprised if that actually produced a different result. Be really surprised. Let's just to be cheeky. We can try this. Should we get that? And it would be so dumb if this worked. I would not be thrilled. So, the game's running again, which I'm not very happy about, actually. Bug's still there. Reason I'm not happy about this is that this kind of logic really should have worked. And I don't like that that was different. So I'm going to revisit this. Granted, I do think, I'm not really sure which of these, I mean, this would like clearly be more Yeah, maybe this is more clear to just do this as well to get this flag. Just seems a bit weird. But so I mean, that's what this logic was designed to do here. Like, overflow can only happen when adding two numbers of the same sign and getting a different sign, right? So what that logic was doing, if we take a look at this, I don't want to move on before like at least understanding this, why this broke. Because like, so we're basically checking for addition. We have overflow if the left hand side bits are equal and the right hand side bits are not equal. Because we're adding two numbers of the same sign and we get a different sign. So that's why I check. I guess this would be better here because that's going to check if... No, that's going to check if they're both 1. That's why I did this. You check if they're not equal and then invert that and you'll get if they're equal. So we want that to be the case and we want these two to be different. So that's this. So this makes sense to me. And for subtraction, subtracting a positive is the same as adding a negative. So conditions that give you overflow are you have the first two bits, like the left hand and right hand side, are not equal, and then the right hand side and the result are equal. Right, so that's what this is doing, checking if left hand side and the right hand side signs are different, and then if the right hand side sign and the result are the same. So that was my original logic. And that makes the game run again. And I kind of want to keep it this way just because, I mean, we found a source that could give us the truth tables on that. Crisis I can compare against the assembler. But is that helping? Too many windows. Right, so we got our prologue and stuff. And what is this doing here? SBB. Yeah, it seems to be only doing one add, but SBB is a subtraction. Subtract with borrow. And shift like XOR compare. So it doesn't add and a subtract. It may be better without optimizations. I'm not really sure it's going to be that much more clear, though. I don't know of anyone that's reverse engineered vertical force. If not, I mean, this should be... If we just do that, it should be the same, right? How do I recompile this? Does it just do that? So you see, it may be better without optimizations. I mean, we'll get a bunch of other stuff though, like this. I'm not sure that was more clear. So it looks like ESI and EDI are used for the actual arguments here, which is what it's doing here. And RAX. Or 640 here. I'd kind of just rather compare these to what the other code would give me. Oop. That's it. I did not expect that to be less code. Either way, though, this isn't particularly clear to me. Like, for example, here, we push EDI into ECX, or move it into the ECX, then we add with ESI. So I think this is our original add here, the overflowing add. And it looks like here, the subtract with bar RAX from itself. I guess if these triggered an overflow or something, I'm not really... Yeah, because this is still 32-bit addition. SPBRX, RX, and EX1. Oh, is it more? Yeah, I'm not finding this very clear though. What? Why did that not work? Oh, this way. I just want to look at what the overflowing add is. So this just adds EDI and ESI here. So 56, you could test your sub overflow logic by taking the ones complement of right hand side and use the exact add logic. Yeah, I could do that. At least to compare them to each other. But again, I still actually think the logic I had here was correct. It just is so weird to me that theirs was different, right? Because like we have a source that clearly lays out what we should expect here, right? We have a source that tells us basically exactly how to find the overflow here, and our logic matches that, right? Yet Mednafen is somehow different there. And that's the thing that's bugging me most here. I think it's so weird that they're able to, that they have something different here. Server, why not type the logic out super explicitly and compare it to using assert equal? Well, because I know they're not going to be the same. So I don't know if it's something else that's doing differently and it ends up working. I'm not really sure. It's again when I make my logic match there, then it doesn't work anymore. Server, you spend a whole lot of time thinking if it is the same for claiming that you know it is. Yes, because you just keep telling me different things to try, so I keep staring at it. Yeah. I'm going to move on, though. I'm going to move on. I'm going to move on for now. So after that, we have compare, which is basically doing the same thing. It does a subtraction, but that doesn't actually store the result here. But it still sets the sign and zero flags, and it also sets the overflow and the carry the same way it would when it was just doing the subtraction. And that's, again, what we have here. See, the logic is the same, LHS and RHS. Only this time we don't do anything except because here sub and set flags. Yeah, we'll still set zero and sign. It will still set overflow and carry. Really quick here, I'm going to look at set SZ. Maybe set SC isn't here. Okay, apparently I'm not awake enough to do this. And I'm getting all backseat driving right now. So I think I'm just going to cut the stream off for now. Because I'm apparently not in the right headspace to do this. So, thanks for watching, guys. I'll see you next week.